Hi, I'm David Mogollon. I'm the editor of Industrial Water World and Water and Wastewater International for Penwell Corporation. I'm here at the American Waterworks Association show in San Diego with Carlton Qualo. He is the Vice President and General Manager for Telog Instruments. He's going to tell us about some of the latest things they have that they're displaying here at the show, and we'll talk a little bit more in background on what some of the other things the company has in store.
All right. Well, thank you so much. Yes, we've been in business for about 25 years. We've been in the remote data acquisition business, so we work primarily in collecting data from the field, bringing it into our software so that our customers can then view it on their desktop. One of the things that we're really highlighting for this show is our new hydrant pressure recorder that can also capture impulses. Typically, these have been around for a long time. Typically, our users use them for customer complaints, pressure complaints. So if someone says they're having low pressure in their house, they'll hook up one of these on the hydrant and another one on like a garden hose adapter or out on the hydrant itself, so that they can do a comparison from the pressure on the street to the pressure in the house. That's probably the #1 application for these devices. But then, in addition to that, you can do things like calibrating hydraulic models, do C-factor testing. It's a very useful device for collecting data about the distribution system in the field. But this new one, this gold one, also captures water hammers. So the importance of that is that with water hammers, you can damage pipes. You've probably all experienced them at a house at one time or another where you close the valve and the pipes rattle. Well, just think of that on a large scale. Think about big valves, big pumps. When those shut off too fast, you send this huge energy wave down the pipes, and that can damage pipes. It can actually break them. You can get water main breaks from them. The other issue is that you can get what's called a negative pressure event. Which is what? Well, with every pressure wave, there's going to be a peak, but there's also going to be a valley. So that valley is a negative pressure event. And what can happen is, because of that negative pressure, instead of the water pressure pushing out on the sides of the pipe, you have it where you're actually sucking in. So if there are any cracks or leaks, you'll suck in whatever is nearby. So negative pressure events are a bad thing. With our devices that, as I said, they collect data in the field, bring it back either by directly connecting to them, or we have the option of having a number of communication options. So we can collect the data in the field from flow data, level data, water quality. A whole variety of parameters can be captured in the field, and then with various communication options brought back into the software. So things like sending things wirelessly through cellular has become a really big one. So we have, I'd say 90% of our remote data acquisition now uses cellular as the main means of transferring those data. And then those data can be brought back into our software. Now, what I showed before was our hydrant pressure recorders, which can be brought back into what I call our Telogger's Lite software. It's very inexpensive. You can load it on a laptop. Very easy to use. What we're seeing here is more of a big system. This goes into our enterprise software. Here it's SQL Server database, it's a historian, and you can share data with things like your SCADA platform. You can share it with billing packages, other historians. It's a very powerful overall system for collecting remote data from the field and bringing it back. Here we can see, as before, we were talking about the hydrant pressure recorder. So you have it on the hydrant, it's collecting data. Here's some typical data from looking at on a hydrant, where you can see the time, and then what we just jumped to there is actually looking at an impulse. As you can see here, this is where an actual water hammer event has happened. This is about 10 seconds. So that's about the typical length, actually. They last somewhere between 5 to 10 seconds. And with that ringing pattern is fairly common. And with that new hydrogen pressure recorder I was showing before, you actually can capture the waveform. Here what I'm showing is a view from that enterprise software that I was talking about. One of the ways you can share the data is through our web module. And with the web module, this is the type of data that you would see. You just enter your username and password, and there you can see the actual graphical data. Here, this is from a creek site, so we're looking at the creek level along with, over here we can see where it's rained. So we have rain data, and you can see that the rain data has had an impact on the creek level as it's been risen. So you can see the correlation between the two. Very easy, very convenient way of sharing data with a large number of users because all they need is a web browser to be able to see it. As I said before, we make a number of devices that can go in the field. Here's one. It has one of our RTUs in here with a cellular modem, battery operated. You can put these in virtually anywhere. It's an EMA 4X box. And this is what would actually be collecting the data and transmitting it back. So if you want to go big with our enterprise system, this is a great product for that. If you want to just collect impulse data and just use our HPRs, you can use those with just a laptop.
Beautiful. Wow. Well, I want to tell you how much I appreciate you giving us a tour of the booth and everything you have, and good luck at the show, and I hope you have a great year.
Thank you so much.
Thank you.
Bye.